So I thought I'd just put together another little video on partial fractions for a particular kind of example that I haven't covered in the previous videos. And that's when you have the same degree on the top and the bottom of your fraction. Now the degree means the highest power of your polynomial. So here's an example where we've got the highest power there is x squared, so that's of degree or order 2. So we've got the same on the top and the bottom. What we've looked at in previous examples is where the top is always less than the degree of the bottom. But when we've got it like this, it's like having a top-heavy fraction when you have numbers. So for example, if we looked at the situation where x was 0 on this one, we would get the answer of 6/4, which is a top-heavy fraction. At that point there, it would be equal to 1.5. We would turn that into a mixed number. Now it's this one part that we're interested in. So when those two orders are the same, it's possible that we could have a whole number come out of that and then some remaining fractions. We need to be able to do that algebraically. So what we do is we turn that into a whole number a that could be at the start of our fraction, and then add on the rest of the fractions just like you would normally do to separate out your partial fractions. So the only difference here is if the order on the top and the bottom is the same, then you have that whole number to start with as a possibility. Now for the A2 curriculum, that's as far as it goes. You can also do this similar sort of method if the order of the top was higher than the order of the bottom, because that also of course would give you a top-heavy fraction. But on the A2 syllabus it only goes as far as checking you know how to do this when the order is the same. Okay, so let's continue on with this example. And what we have there is now equating the top lines. So the 6 minus x squared would then be equal to all of that there if we put it over a common denominator and took the top lines. And then we continue with the same process we've done before. So I'm going to equate coefficients. You can do substitution if you prefer that method. So if we look at the x squared terms, we've got a -1 is equal to minus a, so of course a is 1. And the constant terms look like this, and the x terms like this. Now I'll just tidy up the constant terms a little bit, looks like this, and move that over so we can see that a bit more easily to do our simultaneous equations on those now. If we solve those two simultaneously, we get that b is equal to c and both of them are a half. So pop that back into our partial fractions of f of x. A was 1, b was a half, and c is a half. Alright, so that shows you how to go through one of these examples where the degree is the same on the top and the bottom. If you're finding my videos helpful, then do me a favour, hit that subscribe button down at the bottom and share it with your friends. Thanks.